Hello everyone, C programming session 2. In this session we are going to see variables, data types and standard IO format specifiers. Basically here we have variables. Variable is the one, a storage area denoted by a name. The variable declaration format will be a data type and then a variable name. For example, you can take an integer variable and the variable name is var. Integer var is the format of declaring a variable, integer variable. A variable can be a combination of letters, numbers and underscore as well. It must begin with the letter or underscore. It cannot start with the numerical or any special characters can be included. And in C programming we have that it's case sensitive. Basically with that upper and lower case naming will get differ, that we will see. To get the size of the data type or variable, we can use size of macro to get that the variable or data type, size of the variable or data types. Here we have that some of the data types. Here a character, integer, short, long, unsigned, float, double and void. Character, which denotes a single character value. Integer is the integer which is a whole number, and a short integer is the half of the integer and it's also a whole number, and long integer is somewhat bigger than integer which is also a whole number, and unsigned is the one which makes that integer, character, short or long as unsigned one. By default the data type will be a signed integer or signed short. The float represents the floating point value number with the fractional point, and double is the one which is double precision floating point value. And we have a special data type called void, which is valueless specific data type. It acts like a joker in your cards. Here we will see over there. For example, we can get to that. Maybe we can create a one variable.c. In that we can able to use include stdio.h and integer main, integer or c comma character star or v. Here we can denote something like integer a, and we can denote character b, and then we can denote short c, and then we can denote long d, and then we can denote unsigned integer e, and then we can have unsigned character f, and we can have it unsigned short g, and we can have it unsigned long h, and we can define float I, and we can define double j, and then we can define void star pointer that we will see. Now we have created the different variables and data types here: integer, character, short, long, unsigned integer, unsigned character, short, unsigned long, float, and double precision j. Now we can able to compile with gcc -o var and var.c, so that it got compiled. It's something like we just defined that declared a variables, different variables: integer, character, short, long, unsigned integer, unsigned character, long, etc. And we can see how we can use these, and what are the size of the each data type that we can able to see over there. Here it depends. Each data type will have that different storage area and size. For example, character will be having 1 byte, and it starts from -128 to +127, and unsigned character is a 1 byte, which the value range will be 0 to 255, and integer is 4 byte, and the value range will be minus range over here, and some big number, yes. And unsigned integer 4 bytes, it also starts from 0 to bigger number, and short it starts from contains 2 bytes, and unsigned short contains 2 bytes, and long contains 8 bytes, and unsigned long contains 8 bytes. And we can see the long and unsigned long, it depends on the platform. Now we can see what are the data type. Maybe we can check over here by printing printf. I'm using the %d here. We will see more in the coming up. To print size of is the one which provides the size of the data type or storage. I can use integer. What is the size of the integer? And we have to use YYNPP to place everywhere. Yeah, we can check it here. Character, the size of the character, and size of the short, and size of the long, and size of the unsigned integer. There should not be any change. Anyway, unsigned character, and then unsigned short, and then we will be having unsigned long, and then we will see that float over later. Yeah, now we can print we can ignore the warning. Basically what we have is can have it over here, cat var.c. Here we are printing integer, character, long, short and long, that it involves 4 character 1 byte, and then short 2 bytes, long is 8 bytes basically. Here it contains the data storage size, and it long ranges from the 8 bytes basically. Here next we shall check about that floating point data types. It starts from float, double and long double. Float contains 4 bytes and double contains 8 bytes, and long double contains 10 bytes, so that if we can able to store more data into that, more number of the value range will be higher when the storage size get increases basically. Here we can able to print over here, print we can print float, and then we are checking with the double, and then we can see for long double. Now we can able to compile. Here we have that information. The float is 4 bytes, and double is 8 bytes, and the long double is 16 bytes basically. Yeah, there's some change over here. 16 bytes. It basically that long double is that double the time of double precision. It gives that more precision value, starts from very smaller range to higher range. This will be used in case of the more signal processing with respect to that digital signal processing kind of applications. And to print we have standard IO, which contains printf and scanf. To write it to the console we can use printf command, and to read from the standard console we can use scanf functions basically. And it contains that format specifier, how we can able to read or how we can able to write into that console with the format specifier. We have that different format specifier. For example, C is for a single character, and D is for a signed integer or whole number, and U is for an unsigned integer, and F is to print float and double, and O is to print in the octal value, and X is to print in the hexadecimal value, and S is to print the character sequence of array, and P is to print that pointer of the pointer variable, address location of the pointer variable, that we will see over here. For example, I'm going to read. I'm going into the visual mode so that I can copy and I can remove these things. I'm going to get that the character, enter the character, so that we will know what we need to enter. Scanf, we have to do that with the %C with that, and V is the character, and we can able to print of character is %C, B. Yeah, you can able to see here dot slash var, enter the character. I am entering G. The entered character is G. That it just receives that character input from the standard IO, and it just prints over the standard consoles. I'm just giving another one. I'm just giving W, and the character value printed is W. Basically, it just receives that, gets that input from the standard console, and it just prints over the standard console. That is to get that the value. We to receive the value, we can use scanf, and to print or write into that standard IO console, we can use printf. And to have, in order for printing a character, we can use the format specifier called %c, so that it will print the character value. Similar way we can use for integer as well. Enter the integer. For the integer, we will use the format specifier called %d, and to print we can use %d of a, and we can have it. Next we have that short. For that we can use %h_d. It's a half character for the short, and we have basically a short is half decimal, that we are using the HD, and we have a long. Enter the long %L. For the long, we will be using %LD, long integer. To print, here we are going to compile here, and we can able to give var, enter the integer. Maybe I am giving -345, and enter the character. Character I am entering D. The value is 64. I have something wrong over here. We can compile the var.c, so that it got compiled, and we can able to enter the character. I am entering or got printed. I am entering the integer value 1 2 3 4 5 6 7 8, so that I got printed. And the short range is something like, we can oversee here, and we can have it. The short range is something like -32768 to 32767 and 32,767. If we give more than that value, it will print some junk. Maybe we can give 32,000. We got that 32,000. Maybe for the long, we can use different numbers, little higher number, and we got it print over here. Now we can see, for example, in the character I'm giving D, and for the integer I'm giving 1 2 3 4 a very bigger longer value, and it just gives -1. It may not know how much how it was occupied. That will be get printed. I'm giving now something like 60, some bigger number, and I'm get printed some junk. Basically, when it exits that data storage, for example, the hexadecimal format of here, that will be taken and it will be printed over here. Basically, for example, here we can able to see that. We will see little later, and we should take care that the value of that variable should not exceed its value range. If it exceeds, it behaves erratically. That we should take care of while assigning. For example, we will be having something like it will be with the 32,000, the iterations, that much big number you can use with the short. If it exceeds, we can use integer. If it also exceeds that integer range, we should use the long variable, so that it will get accommodated accordingly. And we can able to print different numbers over here, and in the similar way we can able to print the scan and print the unsigned information. For example, that we can, to scan that unsigned character, we can have to use HHD, SHU, and to get that unsigned integer we have to use %u, and then for the short we have to use HU, and for the long we have to use LU. Now we can able to see here, and it has, I think I have given some yeah, long is H, I given G. That's what the issue. Yeah. Now we can able to print enter the character. Maybe you can give unsigned character is, it's not a character, it's a value of 8 bytes. You can give 123, and you can able to get it printed. To print an unsigned character, it should be a content, and you have to print with that HHU, so that it will be come over there. / variable, I'm giving 123, and I'm giving value of 123, and I'm getting that, and I'm if I 1 2 3 4 5 6, and I'm sorry, I think there is some issue over here in the printing. I'm scanning of the variable in the E, but I'm printing the variable A. It gives the wrong value. I am scanning of the value G and printing here C, and there should be a change needed. I think now it should be fine. 123, and we can enter some integer, and we got it printed, and we can able to 65 535, and we got minus. That's something like we have to make it some, we are printing like here we are printing something like in a signed integer with the D. We have to print it with the unsigned, so that we will get 123, and I'm printing some value, and for the short we can use 6535, so that we got that information, and if we give some value it will get printed basically. And the thing is, since the signed unsigned one will not have that signed information, it can accommodate more number of values. Basically it will be used whenever we need we are sure that it does not need any negative value, it only has the positive value. For example, we have a counter or a counter variable. It should not have that does not need to be a minus. Negative counter will not be there. It should be a positive counter. It starts from 0 and keep on counting. We can, in that case, we will be using that unsigned integer basically. And we can have it something like var.c, and we can able to get that float and double with the, for example, we can print out enter the float, and for the float we will be using %f, and we are getting in the I, and we are printing the float value with the %f. The I is the float, and we will be having a double. We can able to scan off with the %f. The variable is j, and we are going to print a double, and the format specifier is %f, and we are printing over here, and we can able to delete the rest of the things. And now we can able to see gcc hyphen o var and var.c. it contains %f and the double. For the double is we have that something like this, and for example, that the float we can use %f, and for the double we will be using lf, and for the long double we will be using L capital F. We will see how it prints, and I am entering 2.3.4, and the value is coming there, and I am entering the 34 point some junk, entering, I am getting the value, and also I am printing 4 dot longer value. You can able to print the long double, and we are getting that. Basically that the floating point representation, when it goes bigger, it will be rounded off, so that we will be getting that precision accordingly. And we have that different types got printed, and we can able to get scanf over here with the format specifier. We can use %L for the long, and then %L for that double precision, long double, that we can able to see. And also now you can able to send that arguments to the command line arguments with that integer argc and argv. Basically the program receives the inputs from the command line, and it prints, and it will be available to the main function of the C program that we will see over here. Basically here we will be having argument.c, not this one, .c, and include stdio.h and integer main, integer argc, character star argv. Now it has that information here, that For example, I can able to printf argument count %d, integer is %d, argument count, and gcc -o argument .c, and we can able to give /arg. It has been given with the one argument count. If suppose you are giving different 3 arguments, then it should come as 4. Something like different arguments you can able to pass it to the main function. You can able to get that information in the arg value that we will see here. For example, I am just giving 2 arguments, printf 1 colon %s to print %s to print the character of sequence, and argv of 0. I am going to print that second one with the arg1, so that we should be taken care that we are passing expects character argument, but we can able to see here we should here the mistake is that comma is missed. Now we can able to see whether compile. Yes, it compiles, and I'm giving arg hurry. The first argument is arg, and second argument we can getting hurry, whatever the information we are giving. Basically it gives that this gives that flexibility to give the input to the program, basically. Yeah, thank you for watching. Have a nice day. If you are interested, you can thanks for watching, and you can subscribe me for updates. Thank you.